Hey guys. Alright, so today we're going to make a bolt probe. So we're going to use this little machine here, this 6-in-1 mini machine, and we're going to see if we can cut out one of these. So this one was actually made on this machine, so I'm fairly confident that it'll do it. So it's going to be some little bit of chip making and some cuts here. So why don't we just get to it? And I think we got everything we need. All I gotta do is just turn this thing on and get the cutting. So before we get too carried away, let's get it down to size. So, alright, let's start. Alright guys, let's see here what we got and what size that is. So, okay. Alright, it's 185 thousandths. We're making this for a 177. So let's shoot for 10 under that. So let's make it 165. And let me see here. So our bleed screw on our cross feed is a M10 by 1, which means it's 39 thousandths for 1 revolution. Divide that by 10. Which will work out real well. So that means each mark on my dial is 39 10,000ths or 4 thousandths. So I need to go in 2 marks and that should be the number. So 1 mark and measure it. So let's go continue on. Okay guys, so that was, I turned it in about 4 thousandths, and that's 4 thousandths per side, so we should have 8 thousandths off the diameter of the part. And let's see what we got here. And we got 9 thousandths off the diameter of the part. So, that's pretty close, so let's continue on. I got one more cut, and then we'll start whittling this thing out. Guys, now let's see what we have here. That's about, we want to aim for 65 and we got 67. So I'm happy with that. Alright, so now let's get ready and let's start making our first cuts. Now then, what's going to happen is we're going to keep all the material we can on this. So we'll cut a little bit, and then we'll come back and we'll cut some more, then we'll come back. We'll keep this as thick as we can for as long as we can, and that way if we cut all this, by the time we come out here, it'll start moving up on our cutter and start messing with us, and with this, we want to keep that to a minimum. So this is the first section here we're going to cut. We're going to come in here, we're going to cut a little bit, come in here and cut a little bit, and take it back until we're got it to the length we want, and then we'll start grooving it, and that's a whole different process on itself, so we'll get to that when we get to it. But right now, let's get started. Yeah, I can see that one a little bit better. Alright, let's go. Okay guys, you see how I stepped that up to keep it all strong? So now I'm going to come back and just clean that up a little bit, and then come back and I'm going to set up the grooving tool and we'll go from there. So let's do this. And there we are. So let me swap around the grooving tool and we'll continue on. Okay guys, so I've got the grooving tool installed and we're going to put in the O-ring groove. Now the big deal with this is the deal with this machine is I want to keep it kind of low RPMs, as in low power, to where it'll stop the machine before it messes up our part. So the idea here is it could roll up on the cutter, which would ruin, it'd scrap the part. So if I keep the RPMs low enough or the power low enough, it'll stop it, instead of, if it grabs or anything, it'll just stop it. So we're going to make this for a I think the O-ring is a 003, so 003 is the O-ring number, and it's a I think it's 60 thousandths cross-sectional, which is 60 thousandths thickness, and then its ID is 56 thousandths, and its OD is 176, I believe, or 178, something like that. Anyway, so that's what we're making it. We're making it for the 003 O-ring. So we got this groove. It needs to be 60 thousandths wide, and when we're done, the depth or the center of it needs to be 56 thousandths. So let's get to it. And I'm kind of feeling it, you know, figuring out how much power I need and what it takes to stop it and everything like that. But I'm trying to keep the material back towards the spindle as thick as I can, to where it's strong, you know. And the closer I get to the spindle, the more, the stronger it becomes. The heavier cut I'll be able to take. So right now we're just grooving this thing out. Let's check our dimensions and see how we're looking. Alright, so that there is 59.5 thousandths, blah blah. So we're, I don't know, maybe it could use a little bit of relief. So I don't know, I'm pretty happy with that. So let me see here, let me get it out my tool I made to get in grooves like this. You know, because it's kind of, small, and alright, so it's about 65 thousandths. So let's make it maybe 50 thousandths. Now, you know, when cutting the groove, it's better to have it too small. You don't want to put the O-ring on and have the O-ring stretch. You want to put it on and just, you know, have the O-ring loose on there, because, let me see here. Right there, the back side of this, the air is, right here is the pellet, and the air is pushing back this way. So the back side right here is where it seals, and then it seals around the barrel. So the front and the bottom of this are just filled with air. So right there is the sealing surface, and then the barrel's the sealing surface. So it's you know, when you're working on this, make sure you don't, you know, scratch up this here when you're taking off your old O-ring or whatever you're doing, because that's actually a sealing surface. And as far as the center of it and the face of it right here, it really, you know, it could be here to there, because the O-ring, that's, you know, the air is pushing the O-ring away from those surfaces and towards the barrel and towards the back of the bolt. So, so we need to take off, we need to take it down to 50, so take off 15, I believe it was. So let's just go with it and take off a little bit more. Let's check the sizes again and see where we're at on that O-ring groove. Alright, so we're 6 thousandths over, which is good with that. So let's check the diameter. Alright, we got about 55 on that, so I'm calling it on that. So let's continue on. Now, the magnet diameter on the bolt probe is, I believe it's 109 thousandths. It's a, let me see here, it's a 7/64 drill bit, I think. 109, yes, a 7/64 drill bit. So we got to make this between, let's try to make it 111. This is back here. So let's try to do that and we'll go from there. And like I said, you know, when you get back closer to the spindle, you can take heavier and heavier cuts, and you know, just get more and more rigid. So let's see what this is real quick, get a reference. And like I said, I think we're going to try to make it 111 thousandths. Okay, so we're at 115. So that ain't too shabby. So let's continue on. Alright, so let's alright. Let's see how much we're over. Okay, 120. Okay. Okay, so let me see here. We're a little bit away, maybe 2 thousandths. I don't know. I think I'm gonna. I don't know. Let me take a cut up to that and let's see. Don't need much. Nope. Okay. 110. So, alright, so let's finish it up. Let me see here what I need. I need a little file. Clean it up a little bit. Oh yeah. Okay. Alright, let's part it off. And there we are. So let's clean up the edges with the file a little bit. And there is our bolt probe. So we'll just insert in this when we prep the bolt, and we can, you know, slap the O-ring on here, and away we go. So, all right, guys. Thanks for watching.